Hi, DD Solar here. This is a quick demonstration of the auxiliary cooling fans I installed in my solar-powered inverter. It's part 2 of the last video where I showed how to install some cooling fans, extra cooling fans, in a solar inverter or similar pieces of equipment. In order to get up and running, I used black tape right here, paper tape, to create shrouds or ducts over the auxiliary fans in order to pressurize the case with air. And because the inverter is mounted in an upright position, you can actually see the inverter right there. The heat will naturally rise, and these fans, although they're 24-volt fans, they're currently running at about 10 volts. They are enough to cool the system down. Here's a shot of the inverter in operation. You can see I'm getting about 600 watts, and the temperature is 31 degrees Celsius. Now, in this particular inverter, it's brand new. I haven't disconnected the internal fans that are under internal control. I've recorded a few clips of what those internal fans sound like. This is a Generation 2 model of this inverter, and the fans are a little better, but they are extremely annoying to listen to when there's cloud cover. They spin up and down, and they change their RPM, they turn on and off, and really it makes no sense at all. Ironically, at lower wattages, this inverter overheats. Because the fans are not intelligent enough to be turned on at those lower wattages, the temperature creeps up over 50 degrees Celsius. That's just too hot. At higher wattages, such as what you see here, about 600 watts or more, the inverter is smart enough to turn on the fans and run them at a relatively low speed. It's a shame it doesn't just turn them on low and keep them on low when it's over 50 watts. That would be ideal. In order to truly test on camera this type of cooling setup, I have to disconnect the internal fans because otherwise I'm kind of cheating. I have another inverter. It's not the one here, but it's the same type, and it's the 22 to 60 volt model. That one runs at a lower power output, and because of that, the fans are not intelligent enough to turn on, and the inverter goes over 50 degrees Celsius. This inverter is also laying on its side. As a result, the cooling in it is pretty poor. But with my auxiliary fans running at a very, very low speed, it stays at around 35 to 40 degrees Celsius all the time. The fans I'm using here are 24-volt brushless DC fans, and they have sleeve bearings. As a result, they are almost impossible to hear if you run them at a lower voltage. To control the fans, I'm using the following. It's a Drock DC-DC converter. This DC converter is pretty nice. I do like it. It's running directly off of solar panels. So the solar panels come in here. The fan output is here, and I can hook as many fans as I want. And you can actually go to a set, and you can change the voltage up or down. Right now I'm running them at about 10 volts, which is really just idling. And I really like this little board for controlling fans, and I think it's going to be my go-to controller now for all these projects. Eventually, this board will control the fans for more than one inverter. Right now, it's only controlling the fans for one inverter. I do not need a thermostat because the way I have it set up is very, very dirt simple. When the sun shines on the solar panels outside, this board turns on and starts running the fans at an incredibly low RPM. The fans will probably never wear out because they're running well below their max RPM, so their lifetime will be greatly enhanced. As long as there is some air pressurized from the bottom of the case, there is no way the inverter can overheat running at the power levels I have it set up for. Here you can see the voltage of the two 100-watt solar panels outside my workshop, and that is directly powering this DC-DC converter, which is powering my fans. As long as the sun is shining or it's daytime, there's enough power to run the fans. These panels are also powering my camera lights, charging my solar generators, my USB devices, my cameras, my phone, and anything else I want to charge or run in the shop. And all of that is done through this fuse block here. If you're interested in this sort of thing, referring to boards with wires running all over them, check out my Solar Power Equipment Board series. In that video, I'm showing how I wire up the board, how I install everything, try to get it straight and wired up and fused. And that is an ongoing series. I don't know when it'll be complete. This next part of it will be uploaded pretty soon here. This is my other small workbench that I first started recording videos on. On this workbench for a very long time I've had this power supply here, bench power supply, putting out about 10 volts. And this is the first inverter that I use the auxiliary fan setup on. I have some scrap material here to make fan shrouds. The fans are in there, they're kind of hard to see, but they're in there. And these are just normal DC brushless fans. And this inverter, ironically, running at only 100 watts, will actually overheat. However, if you look closely, you can see the temperature is 38 degrees Celsius. You can almost not hear the fans. They're very, very quiet. So this was the first auxiliary fan setup I installed, and it's working perfectly. It also works at higher output levels. Eventually this inverter will be installed in a more professional setting, but right now it's just laying on my workbench, and I've got a few solar panels hooked up to it to get me some power. This inverter actually has, as far as I know, never turned its internal fans on, not one time since I bought it. That is because I run it at a lower power level, and it's not smart enough to look at the temperature and use that for feedback to run the fans. It appears this inverter only uses the power output to determine when to turn the fans on. I'm not sure it looks at temperature. It might, but it doesn't seem to. Anyway, that's all a moot point for me. I like to control the fans myself. I like to run my inverters at around 40 Celsius. So I'm back out at the workshop. To close this video, I have a plan to disable the internal fans in this inverter with a switch or by just cutting the wires. Now that's not necessarily a bright idea. You really need to know what you're doing to do something like that. But my fans will come on automatically from an external and completely independent system. They will not require user intervention to power on. There is no thermostat. They will always come on, no matter what power level the inverter is operating at. That's generally how I design my systems, so I can run my inverters at a much cooler temperature and have control of the fans. This in turn will extend the lifetime of the inverter because it's not running as hot. Electronics need to be cool, and the hotter they get, the harder they run, and the shorter the lifetime. With a grid tie inverter, you want to maximize lifetime so you can get as many kilowatt hours out of it as you possibly can. I hope you enjoyed this video, and I hope it helps someone. Until next time, see you later.